I'm Mr. Quell, and today we'll be solving solutions of systems of inequalities. This is the Common Core standard: represent and solve equations and inequalities graphically. Our first step in solving and graphing is finding the point of intersection. We solve that by setting our equations equal to each other by setting them into equations themselves. We then form x equals 4 minus x. We then add x to both sides. X then becomes 2x. That becomes 4 still. Divide by 2, x equals 2. Plug back in, y equals 2. Y still equals 2. Therefore, our point of intersection is now 2, 2. Looking at those equations, what might this graph look like? That's what we're going to explore. Draw an axis. Plot the general point 2, 2 somewhere in here. Plot your graphs. Make sure to have a dashed line because it is a singular sign, not an equal sign as well. Only the greater than or less than. So we'd have a sign like that. Same case here. Go up to about 4, wherever you think that is, and go down to our intersection point, and then go down to an intercept, and up past it, and then shade in our points, or our solutions. We then have above this bottom line, lines going like this. That's our solution for that line. Our solution for this line is below the other one, that one. So it'll be going like this. Where our lines intersect is where we have a solution. Now, we can test points in here, make sure it works. -1 seems good. -1 in here. Y is greater than -1, checks out. Y would be also less than 5, checks out. Y would be for points of -1. Y would always be somewhere in between -1 and 5. And the graph reflects that. Now, for our secondary problem, we're solving this system. Now we have a greater than less than symbol. So it will be a little more different. We'll have a straight line and a solid line at that. So in this case, we'll do the same thing. Y equals x plus 2, and y equals 1 minus 2x. We set them equal to each other. Now, if you notice, we might get a fraction, so be ready for that. Subtract 2 from both sides. That becomes -1. That becomes 3x. 3x equals -1. Divide by 3, x equals 1/3. Plug into our equations. 2 minus 1/3, or -1/3 plus 2. And -2 times -1/3 is going to be positive 2/3. So 1 plus 2/3. Now, what do these have in common? They're both 5/3. 6/3 minus 1/3, 5/3, and 3/3 plus 2/3 is also 5/3. So, therefore, we do have a point of intersection, -1/3, 5/3. Now, craft your axis and find a general fractional point pretty close to the axis, maybe a little bit below a certain level because we have fractions. So about here seems good. We then have x plus 2. We'll then graph that slightly above because, of course, 2 is greater than 5/3. You can also graph somewhere in this general region matching the axis and matching the trend of the graph. We'll graph now a solid line through these points, and since it's less than, we will have lines signifying where the graph resides in the inequality. We will then graph the other line. We can see it's at 1, so about halfway down here. Mark it. Negative 2x is a much steeper thing than positive x, so we can graph it like so, making sure it's a dashed line due to the fact that it is only a greater than sign, not a greater than an equal to sign. And so it is now a greater than this. So we graph like so, and we can see the intersection of these lines is on this right side. We can expand out the lines if need be to see that our solution is somewhere in here. And so if we pick a point like, say, x equals 2, since that is definitely in this range, we can say, okay, our upper bound will be this line since it crosses over to the top. Our upper bound will be 4, and 4 will be included since it's a solid line. But our bottom bound will be 1 minus 2 times -2. -4, 1 minus 4 is -3. So our bounds will be 4 and -3 for a y value at 2, but the bottom will not be included. So it's any value greater than that, up until 4. All right, that was how we solve systems of inequalities.